I call this lecture Special Senses because we're going to be dealing with taste and touch mostly. Taste and smell mostly, but also a little bit of touch. I grouped taste and smell together for a discussion because these are both senses which use chemicals have to be detected with chemicals, so they're called chemoreceptors. In other words, it takes some sort of chemical in solution before those action potentials are generated. All right, so once they're put in solution, though, the action potential is generated. And again, with taste, there's 4 types of receptors, which we'll look at a little bit. But smell, you can differentiate a large range of different odors with the sense of smell. Our sense of smell is not nearly as sharp as some of the other animals, but we can differentiate quite a few different smells. Now, again, I group these two together because these two senses do seem to complement each other. If you've ever had a really bad cold, where your nose is congested, sometimes food doesn't even taste quite as good, simply because part of our sense of smell, does also involve our taste. All right, let's take a look here at the nose, the olfactory epithelium. This is the epithelium that is designed to detect your sense of smell. If you look at the diagram here on the right, you see this is your upper respiratory cavity, right through here. Through the bones of the ethmoid bone, you have little tiny holes that come through, and the nerves are going to be branching off through here, and their little cilia, or hairs, are going to be spread out throughout this layer of mucus. Now, this mucus is constantly regenerated, replaced, so every time a new odor comes in, and that's all that's going to happen is when you inhale a gas, some of those gas particles are going to stick inside this mucus. Once they're stuck on the mucus here, they will stimulate these protein receptors on these cilia, and that's going to trigger an action potential. It's going to carry an action potential or nerve impulse through the nerves, through the axons here, all the way through the ethmoid bone into the olfactory bulb, where they'll synapse with other nerves here, which will eventually form the first cranial nerve, the olfactory nerve. Now, from the olfactory bulb, they'll become the olfactory nerve. Those impulses will lead to the temporal lobes of the brain and become part of the limbic system. That's why the sense of smell is such a strong stimulant for memories and for emotions. Now, the other hazard about these cells like this is they are directly exposed to the environment, so they can be easily damaged. Therefore, these cells do regenerate quite frequently. Same with this mucus layer is constantly being replaced. Now, your sense of taste obviously is primarily centered on your tongue, and on the tongue you're going to have all these little taste buds. But the taste buds are going to be located not just on the tongue, but they'll also be found in the soft palate and in your cheeks, and even some on the pharynx, upper part of your pharynx as you go down. Now, the taste buds just don't hang out there by themselves. If you look at this picture over here, you're going to have little tiny projections called papillae. And there's different kinds of papillae. As you see on here, there's fungiform, circumvallate, and here they all are for you. The fungiform papillae, filiform, fungiform, circumvallate papillae. In this picture here, you're looking at the circumvallate papillae, but mostly you have fungiform papillae located all around your tongue, well as filiform. And it's on these here that you're going to have the taste buds actually going down into little crevices here on these papillae. Now, these papillae, the filiform papillae right here, these are the smallest and they're cone-shaped. Fungiform papillae are a little bit larger and they're mushroom-shaped. And circumvallate papillae are going to be circular-shaped. Most taste buds are going to be found in these last two, the fungiform and the circumvallate. Now, the actual taste buds themselves, Again, if you were to kind of look at the circumvellate papilla here, and these are generally going to be found in the inverted V in the back of the tongue like this. But this is true whether you have the fungiform or filiform papillae. They're all going to be basically the same, just these are going to be really large here, the circumvellate. All around the sides here as they go down, you're going to find these numerous clusters of taste buds. That's these right here. Now what has to happen is this. In order for you to taste something, the food has to be put into solution. Once it's put in solution, it can penetrate these little small spaces here and go down. And as they go down, little tiny hairs sticking out of the taste buds are stimulated. Again, it's a chemical reaction. They will stimulate those taste buds to generate an action potential which will be carried through here, through several nerves. Most of the nerves are going to eventually become part from the facial nerve, the glossopharyngeal nerve, and the vagus nerve, depending on where they're going to these axons are going to come from. But they're going to basically send the message to the brain here about taste. The taste sensations, depending on the receptors you go, you can be talking about sweet receptors, sour, bitter, or salty. Now, most people are kind of fascinated on the tongue where these are at. Generally, your sweet receptors are going to be more at the tip, although you can actually taste all these sensations all over your tongue. Most of the sweet receptors are going to be located on the tip. The sour are going to be more on the sides and towards the back. The bitter receptors are always way in the back, and the salty receptors are going to be located more on the front and sides of the tongue. Now, you have other tastes here. Some researchers are pointing out that you have a fatty taste for certain fatty acids, as well as a taste here for tasting certain proteins. But those are not generally recognized, so we're going to keep them out of this class for right now. But be aware that they are required in some other classes. Finally, let's focus on the sense of touch, or as I put up here on this handout, ectoreceptors. Depending on how deep these receptors are in the skin, that's going to determine what you touch. For example, a light touch across your skin. That will be stimulated by receptors very close to the skin's epidermis, and those will be the Meissner corpuscles. Those will be the ones if you were going to detect some insect crawling along the back of your hand or someplace, being very light, they might stimulate the Meissner corpuscles. If there's a little more pressure, so there's a little more weight tied to it, going a little deeper into the dermis, you're going to activate Pacian corpuscles. And they're going to send a message to your brain, that you got something a little bit heavier on there. Deep pressure. Now, we've all experienced pain. The pain receptors are called nociceptors, and temperature receptors are thermoreceptors. I group these two together because basically what you're looking at here is they're both bare nerve endings. That means that they respond to the least amount of stimuli. It doesn't take much for them to actually start an action potential and send a message on to the brain. Like I said, they are the least specialized, but they are by far the most numerous.